Hello Earth, welcome to episode 47, season 2 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. If you're just tuning in for the first time, I recommend you go to github.com/autocodinal/cell. Link I will paste in the description. And we're going to continue where we left off, which is yesterday. We were working on native calls like plus, minus, equal, and we're actually in the process of implementing it, and we have a little to do here. Today is going to be a short session, unfortunately, but still it's going to be a session, which is what matters the most. So we are basically going to write a test with a message with multiple paths for non-native call. Yeah, that's a great idea. So we're going to go to cell do, and here where's our logic that gathers the paths, because we could have a message with multiple paths, right? So here we're going to take care of yeah, here we did here. Yep, like that. So we need to just write a test for it, right? And again, I'm taken by the desire of making these tests more legible, really. Yeah. Let's go and test sequence. We do it here. Enter all the errors. Here we test the plus. So we'll reset things again here. We're just going to test it afterwards. And let's just say if you pass multiple arguments, so we could do it something like this. Look. We could actually do something like this. We could put something like, actually we don't even need to set it, right? Let's set call. Set call to I'm trying to see what's the context in which I am using. This is when we find a message here. The message should not be in the definition, it should be in the call, right? Yeah. So we put the call and we basically say we're going to do, it just takes a single message. And it's basically just gives one, right? If I remember correctly, you just do it like this. basically a call that returns its own value. I would do it actually like this. The one will be just add message. Good. And then I would do something like I would put I call I will do at def with bar 1 I should do the here, of course. Would be def foo2. And then what do we expect to find? You can be lazy and just run it. Sorry, it will be node cell. Yeah, this is correct, right? This call looks very weird. Actually, it's fine. Yeah, the value is var1 foo2. That's perfectly fine, actually. That's correct. Yeah, it's correct. Yeah, call. It's just a lot of data because, of course, you have the message in the expansion, the sequence. This works. It's correct. If I just some let's fix this. That. Okay, it works. And if I would comment out this, it would fail. It would just give me the first path. For definition, it would give doesn't even give a message. That's weird. I would expect a message of a single path here. This is weird. It will be bar 1, exactly. It's the first line. The definition is the same. This this part is also this. No, this part is already weird. No, actually it's correct. What should be different is what we do in the expansion. Why is there no expansion? Def bar 1. Why doesn't it pick up the first line? That's so weird. It's so tempting just to move on, but I need to understand why it's not giving anything here. That's so weird. Why is message not being set? Why it's not being set? No, here it's perfectly correct. It's fine. The message. It's a single path, right? And then if I go to self-do, have the message. Yeah. The message is only place one, so it's pretty elegant. Okay, bar 1, it's right there. The stripper doesn't do anything about it. Yeah, message bar 1. Why does it work? Here you have the message with 2 lines. This is so weird. Why is it split in 2? Yeah, because the message is just basically broken because it should be a list of paths and it's just one path. That's why. Okay, that's why it was split like this. Still don't understand it fully, but I really want to move on. So I might regret that, but at least I understand where it was wrong. Now it works, right? Yeah, it works. We have a little bit of repetition there in the code, but not much. Of course, we need tests for native calls. This to me feels like such a big undertaking, this whole thing. It's I sometimes I feel a bit lost on how to continue, because I fully intend for this to be useful, even in the short term. It's like, okay, now where do I go? I think what corresponds is to annotate the code that we have changed, because this is already working quite well. It's a pretty function. I don't even I guess we can be nice and comment this as well. Can just leave the fragments. Function text, and if it matches something that looks like a number, returns it as a JavaScript number. Otherwise, it returns it as text. A number is defined as an optional minus followed by an optional number of digits followed by an optional dot followed by a mandatory one or more digits with nothing else before or after. We have that function annotated now, and we go to var previous value. So where's a good place to do this? This var previous value. Here we definitely need a target path, a value path, the context path we don't need. The value, previous value, honestly we don't get it. We don't need to get it, we can move this below. The test should still work. Yeah. We will now do a couple. We will do check whether this the prefix is gonna go first. Path is the first prefix. If we are here, we know we are dealing with a call. A call has a message that could have one or more paths. We don't want to execute this call for the second path or subsequent paths with the same prefix, the same call. Just for the first one. Therefore, we now write some logic to see if this path is indeed the first for its call. To do this, we first take the prefix of the path, which is the target path, without the equal at its end, plus at and the first of the value path. We then get all the paths and see what's the position of this path in all of them. This is currently extremely inefficient, but when we decide to improve get, we can also do this in a better way. More efficient. You see, I could just return false. The moment you find something that doesn't match, it cannot be, right? we stop and find the I think that would work, but I want this to stop. If I find something that matches, then I want to know it, but I also want to stop the iteration. Honestly, I don't need to know more than one, really. I don't need to iterate all of them. I just need to look at the previous path. It will be something like this. It will be index equals 0 or paths index -1 length is minus and prefix length, or it does work. We only need to check if the previous path also matches this prefix. If there's no previous path, or if the previous path has a length less than prefix, or if its prefix doesn't match the prefix we have here, then this is the first path for this call. This is not the first path for this call. We return and do nothing else to avoid unnecessary execution. Okay, now we have that. We have definitely improved things. I want to understand what happens here. Yeah, if here there's no native call, then we default to current value. It's not even defined. Oh yeah, it's defined here. Oh yeah, because we start with a lookup, so it will be nothing basically. Yeah, I get it. So what we need to do, what I would like to do here, I would just like to do something like just call it Be right back. All right, I'm back. So let's just annotate this part first. No, this is wrong, right? Yeah. I'd like annotate it twice, right? Varchol, yeah. But before we do that, we need to collect all the paths inside the message, which could be many. For that, we iterate all the paths after paths that have as this one, and return whatever is after the prefix. There's something to be looked at that I will look at the next session, because here I'm missing a variable k and here I'm missing a fixed k, so this is probably a source of errors. It's a source code for epic pulse. And then what else? That's it really. We need to add also neither if or do. Yeah, where is it? It is too. Boom. It's actually nice. It's also probably a more efficient way to do this. They went the same way we did that before, kind of, but there has to be an iteration here so we can stop when something doesn't match. So let's just write it down here. Annotate native, improve efficiency of message retrieving by stopping when not finding a match and accumulating outside the native. Perhaps even you get the message with common code, and then we add the test for native calls. Good. That's what's coming next. Thank you for watching.